What's going on, everyone? All right, 9-1 notes. Hope you scored well on your quiz. Hope you're enjoying Super Bowl weekend. All right, now 9-1 is direct, inverse, and joint variation. So to start, let's talk about direct variation. Now, we did this back in Chapter 2, if you remember. And what it says is two variables, in this case, x and y, show direct variation if y equals k times x. And remember, we would get a y and an x, we would solve for k, then we'd go back and write our new equation with k. Alright, so we did that back in Chapter 2, but we're going to review it here today. And now we're going to have a new one, which is inverse variation. An inverse variation says two variables, x and y, show inverse variation if y equals k over x. Now, because x is in the denominator, we're going to say k cannot equal 0. Alright. Now, looking at the examples, determine if the equations are direct variations, inverse variations, or neither. Alright, now, so pretty much we want to say, does x and y have this relationship or this relationship? Now, the only way we can tell that is by solving for y, by getting y alone. So here we're going to divide by x. Y equals 4.8 over x. So now we have y equals some number over x. Y equals some number over x. This matches the division. So this is inverse variation. Alright, over here again, we can't make this determination until we have y alone. So I got to multiply both sides by 1.5 to get rid of that. So y equals 1.5 times x, which is multiplication, and that is a direct variation. Alright, so we're just describing the relationship between the numbers and variables we have. So y equals x minus 8. X minus, well, it's not multiplication, it's not division. So here we say neither, some say neither. Alright, over here, again, they tried to trick you. We got to get y alone before we can make our decision. So y equals 15 times x. Well, that's k times x, with k being 15. So that is also a direct variation. Alright, so that's being able to identify. Now, let's look at these examples. It says x and y vary inversely. Alright, well, right away, inversely tells you y equals k over x. And that's the first thing we always have to do, is determine which equation are we dealing with here. Alright, and then it says when y equals 6 and x equals 1.5. So the first thing we have to do is, it says write an equation too. It doesn't say solve for k. It says write an equation. It should say and, not and. Alright, typo. Okay, so we have y is 6, so 6 equals k divided by 1.5. Alright, so now we got to solve for k, so we're going to multiply both sides by 1.5, and we get k equals 9. So my equation is y equals 9 over x. Again, I'm looking for the equation. Please take the time to write it. Now it says find y when x is 4/3. So we have y equals 9k divided by 4/3. Now, you can put in your calculator, MathFrac. That's probably the easiest way, but I don't have a calculator with me. So I'm going to go y equals, dividing by numbers the same as multiplying by the reciprocal. So you should get 9 times 3 is 27 over 4. Alright, so 27/4 is your value for y. I hope you remember that. We did ones like that in Chapter 2. Now, here's the new ones. No, I'm sorry. We did direct variation, Chapter 2. Inverse is the new one. So that was a new one. My bad. So x and y vary directly when y equals 8 and x equals 3. So first, directly, we're dealing with y equals k times x. So in this case, y is 8. So 8 equals k times 3. Well, let's get k alone. K equals 8/3. Then rewrite the equation. So we have y equals 8/3 times x. 8/3 times x. Right, so it says find y when x is 7. Well, y equals 8/3 times x, which in this case is 7. So y equals 56/3. Alright, so that's direct and indirect variation. Know how to use it, know how to find your k value, given x and y, and then know how to write an equation and solve for any value. Alright, pretty good stuff. Now, determine if the data is inversely related, directly related, or neither. Now, this is given a table of data, determine the relationship. Now, one way I like to talk about this is if you look at our x value, what's happening here? My x value is increasing, so it's going up. Okay, it's increasing. And if you look at your y values from top to bottom, all right, these are decreasing. All right, they're decreasing. Now, how do you get from 10 to 30? How do you get from 20 to 15? All right, there's probably multiplication happening there somehow. All right, so let's think about this. Okay, 10 times 30, well, you've got to find a relationship. All right, think of if you divide 3 divided by 10 is 3, 15 divided by 20 is not 3, so that's not it. Now, 10 times 30 is 300. 20 times 15 is 300. 30 times 10 is 300, so on and so forth. So that's the relationship. So that tells me that k is 300. So how did I get that? Well, 30 equaled k over 10. All right, and then we'd multiply both sides by 10. So because this is division here, we're looking at an inverse relationship. Now, if your x's are increasing and your y's are decreasing, it's going to be an inverse relationship. And think about this. If your x is growing, right, what's going to happen to your y value? It's going to go down as the denominator gets bigger. As the denominator gets smaller, my x value is going to get bigger. My y value is going to get larger and larger. All right? So as your x increases, okay, as your denominator gets bigger, your number, your y, gets larger. Right? Makes sense. Now, down here, so here your x, all right, is decreasing as your y is decreasing. Now up here we had our x increasing as we were decreasing, so that was that relationship there. Now down here, as your x gets smaller, your y is getting smaller. Well, that kind of makes sense, right? This would be a direct variation. Let me explain why. Let's say y is 217 equals k times 31. Well, if you divide by 31, k is 7. 140 divided by 20, k is 7. 119 divided by 17, k is 7. Okay, so as your x gets smaller, your y gets smaller. That makes sense when you're multiplying, right? If you're multiplying by a smaller number, your result is going to be smaller. So it's going to be less. So to kind of sum this up, as your x increase and your y's decrease, that's an inverse relationship because of the division. As the denominator gets larger, your number gets smaller. All right, and then down here, as your x decreases, your y decreases, represents multiplication, because as you multiply by a smaller number, your result gets smaller. All right, so that's determining it from a data table. Now, joint variation. Okay, now, joint variation varies directly, so it's a direct variation, varies directly as the product of, and this is the important part, ready? Two or more other quantities. So we say it's a direct variation if we're only dealing with x and y, but when we have multiple more than x and y, okay, two or more, then we're talking about joint variation. So here we say z equals k times x times y, where k is not equal to 0. Alright, so that's a joint variation. So these examples says write an equation that describes a variation. So they're all multiple variations. So it says m varies jointly with x and p. Alright, the key word there is jointly, so we're talking about a joint variation. So m varies jointly with x and p squared. So k times x times p squared. Jointly is a direct variation with two or more pieces. Alright, let's look at this one. Y varies directly with x and inversely with z squared. So y varies directly with x. Well, direct variation is k times x. So that was this part. And inversely was z squared. So I would divide by z squared. Alright. Now, C. Y varies inversely with x cubed. So y varies inversely. So that's k over x cubed, because the inverse tells me divide. G varies jointly with B, N, and W, and inversely with V. Alright, so this and I'm going to kind of chop it up into two problems. So I have G varies jointly with B, N, and W. So K times B times N times W, and inversely with V. Alright, that's it. Enjoy the rest of your weekend if you're watching this early in the weekend. If not, you're watching it late Sunday night. I will see you tomorrow morning.